Endochondral ossification occurs during fetal development, by which bone tissue is created. By the time an embryo is 6 weeks old, the proximal bone of a limb, such as the femur, is present but is composed of only hyaline cartilage. The cartilage will enlarge, and the chondrocytes, which are cartilage cells, near the center of the shaft begin to increase in size. As the cells enlarge, their lacunae, which are indentations that the cells occupy, expand, and the matrix of the cartilage becomes a series of thin struts that begin to calcify. The chondrocytes become surrounded by calcified cartilage. Diffusion can no longer occur through the calcified cartilage, so the chondrocytes are deprived of nutrients and die off. Blood vessels grow into the perichondrium, which surrounds the cartilage. The cells of the perichondrium convert into osteoblasts and produce a thin layer of bone around the diaphysis of the cartilage. The perichondrium becomes a periosteum because it covers bone rather than cartilage. Blood vessels then penetrate the cartilage into the central region. Fibroblasts migrate with the blood vessels and differentiate into osteoblasts and begin producing spongy bone at a primary ossification center and spreads toward the epiphyses. As the bone enlarges, osteoclasts appear and begin eroding the center of the diaphysis, therefore creating the medullary cavity. The next major change is when blood vessels penetrate the epiphyses, causing them to calcify. Capillaries and osteoblasts migrate into these areas, creating secondary ossification centers. Osteoblasts continue to form bone until the only cartilage that is left is the metaphyses and the ends of the epiphyses. The cartilage at the end of the epiphyses is the articular cartilage, which prevents damaging bone-to-bone contact within the joint. The cartilage at the metaphyses is the epiphyseal cartilage, which separates the epiphysis from the diaphysis, which is essential for interstitial growth that happens over